Hello everyone, I am Dr. Sirajul Faisi. I welcome you in my YouTube channel. Today in this video, I am going to discuss about matter and measurement. So let us start learning of matter and measurement. So first of all, I want to discuss about scientific methods. A systematic approach to solving problems is known as scientific methods. So observation and experiments, then find patterns, trends and laws, then models, formulas and test hypotheses, and then become theories. And like this. This is what make it science. So a systematic approach to solving problem, these steps. So first devotee and develops Persian optics like this. So chemistry. What is chemistry? The study of matter, what it is, its properties, and what it becomes. So you can see here the solid, it becomes liquids and gases. So matter, anything that has mass and takes up space. So this is the matter, this is matter, this is matter. You can see the oxygens, ethanol, water, carbon dioxide, ethylene glycol, aspirin. Atoms are the building block of matter. So each element is made up of same kind of atoms. And a compound is made up of two or more different kind of elements. You can see in this example. Now, state of matter. You can see here the gas. Cool or complex, then become liquids. Cool, then become the crystal solid. If you have solid heat, it become liquid. Heat or reduced pressure, then it become the gas. So, cool or complex, heat or reduce the pressure. So, classification of matter. You can see the matter, mud. Is it in uniform throughout? No. Heterogeneous. Mixture, mud. Yes. Homogeneous. Example, salt water. Does it have a variable composition? If yes, homogeneous mixture solution, salt water. And no, substance is water, pure substances. Can it be separated into simple substance? Yes, then compound like water. No, element like oxygen. So, mixtures and compounds. Elements, compounds, molecules. So, you can see the atom of an element. Here, molecules of an element. Here, molecules of a compound. Here, mixture of elements. Now, properties and changes of matter. So, physical change in matter that do not change the composition of a substance, change of a state, temperature, and volume. Chemical change that results in a new substance, combustion, oxidation, and decomposition. So, chemical reactions, you can see hydrogen and oxygen gases mix together, burn. When hydrogen burn, it undergo a chemical change to form water, which is a product in the flame. So, in course of chemical reaction, the reacting space substances are converted to new substances. Now you can see the compounds can be broken down into elements. This is the water and broken down in oxygen gas and hydrogen gas. So relative abundance of elements like this, calcium, iron 4.7, aluminum 7.5, other 9.2, and then 49.5 oxygen, silicon 25.7. And in human body, 7% adult, hydrogen 10%, carbon 18%, and oxygen 65%. Now, the top 10 chemicals produced by chemical industries in 2002. Haber-Bosch process ammonia synthesis. N2 plus 3H to give to a molecule ammonia, responsible for most of the fertilizer used worldwide, uses about 1% of all total energy, developed by Fries Haber and Karl Bosch. The trick finding metal catalyst, the bomb. So this is the equation. The bottom line, once you have ammonia, you can make all kind of N-containing compound. Now ammonia fertilizers runoff cause algal blooms. You can see. So now separation of mixtures. How you do the separation? First, filtration. You can see separation, heterogeneous mixture, solid. Here solid substance from the liquid solution. Here liquid. So now distillations. Separates homogeneous mixture of liquids on the basis of difference in boiling point, salt water, boiling flask, cold water out and cold water in, your condenser, clamp, receiving flask. Now you can see distillation, petroleum refining. So petroleum gas, gasoline, petrol, kerosene, diesel, industrial level, air furnace, crude oil. So this is the process. Now chromatography. Separation. Separate homogeneous mixture on the basis of differences in solubility in a solvent or in binding to a solid matrix. Separation technique were critical to the development of the basic theory of chemistry. How do we know there are homogeneous mixture? We can separate them. So chromatography. You can see VED, volume, and GI. So this peak is indicating there are many components present. Now units of measurements. This is very basic. You go through this and memorize it. Abbreviations correctly and name of units and physical quantity. This is the prefixes, how to convert base unit into unit that are appropriate for the item being measured. So more important than it looks. Now volume. Most commonly used metric unit for the volume are the liter and milliliter. A liter is a cube 1 decimeter long on each side. And millimeter is a 1 cube 1 centimeter long on each side. Now the temperature proportional to the average kinetic energy of the particle. In a simple, kinetic energy is equal to half mv square. So you can see this is the body temperature. Water boil at sea level. Water freeze at sea level. Absolute zero, all motions stops. 0 minus 273 Kelvin, like that. So Celsius and Kelvin scale. Celsius scale is based on the water. Now for intensity. A physical properties of substance, intensive, D is equal to M by V. So this is the table. Now certainty in measurements. You can see the different measurement device have different uses and different degree of accuracy and precision. This is gravitational cylinder, this syringe. Here is the burette, stopcock, these portions, red one. A valve to control the liquid flow. This is the pipette and this is the volumetric flask. All is measuring equipment. So ruler measurements, if you want to measure this, if you have centimeter in temperature reading, dozen, volume or mass, so this one is exact and this one is inexact, because if you measure with the ruler, it depends on the perfections, temperature reading, volume or mass reading, things you measured. And here, any conversion fact. So this is the fact 1 kg is equal to 1000 gram. And this. So there are 12 eggs in a dozen. That is the fact. Each egg weight about 550.5 grams. How much does a dozen egg weigh? And how many significant figure in your answer? This is the same. You can see. Accuracy, percent, precision. What is the accuracy? Accuracy close a measurement to the true value. How right you are. Good accuracy, good precision here. Precision, how close measurement are to each other. Reproducibility. Precise but incorrect data are often the results of systematic error. So good accuracy, terrible precision, your calibration is off. And this is the bad accuracy, bad precision. Now, what is the significant figure? The term significant refer to the digit that were measured. When rounding calculations number, we may attention to significant figure so we do not overstate or understate the precision of our new answer. So all non-zero digits are significant. Zero between the two significant figures are themselves significant. Zero at the beginning of a number are never significant. So just revise it. So significance, how you do the additions, multiplication. This is the way that error are properly propagated through the calculations. So dimensional analysis is also important. Why do you virtually all problems in the chemistry have in common dimensional analysis? If you know the dimensional analysis, you can easily convert one dimension to. So dimensional analysis, what do I need on top? What do I need on the bottom? What do I know? And how do I get there? So you will always be given the conversion factor you need. You don't have to memorize them. So remember, you can write any conversion factor to away. For example, 2.54 centimeter is equal to 1 inch. So in two ways we can write it. So the speed of light is this. What is in the kilometer? No, 1 kilometer this, 1 meter is equal to this, 16 is this, and 1 second is equal. Why? What do I need on top? Kilometer. What do I need on the bottom? Hours. So you can put it like that, you will get the answer. Now dimensional is another example. The vehicle assembly building at the Kennedy Space Center has a volume this. What is in liter? So 1 liter is equal to cubic decimeter, 1 decimeter is equal to 0.1 m. So what do I need on top? Liters. And what do I need on the bottom? Building. Now dimensional is example second. An individual suffering from high cholesterol has 232 milligram cholesterol per 100 milliliter of blood. How many grams of cholesterol in the blood, assuming a blood volume of 5.2 liter? So, no, 1 liter is equal to 1000 ml, 1 gram, 1000 milligram. 5.2 blood is equal to patient blood. So, what do I need on top? Gram. And what do I need on the bottom? Patient. Now problem, consider a piece of gold jewelry that weighs 9.35 gram, has the volume this. The jewelry contains only gold and silver, which has the dimension of 19.3 respect. If the total volume of jewelry is the sum of the volume of the gold and silver that it contains molecules, percentage of gold by mass. So you can calculate in this way. This is the calculations. Another look in this way also. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.